Okay, so moving towards the third advanced technique, which is integration by parts. So to start off, integration by parts can be used. So let's start at the very bottom. So integration by parts can be used if you have, so majority of this particular technique involves with product of different functions. So if you are having two different products and two different functions, so let's say for example, one is algebraic, then it's being multiplied to let's say exponential term. So meaning this is the time that you're going to use partial fractions, or it rather integration by parts. So for example, exponential then multiplied by a trigo function. So again, you may also use integration by parts as long as it's a product of different functions. Okay, so if it's purely algebraic, purely trigonometric, so of course the other techniques would suffice. But for products of different functions, the best way to deal with it is to use integration by parts. Okay, so logarithms also. You may also you may also use logarithms because we don't have any integrals for ln, diba? But with the use of integration by parts, you're able to get the integrals of the logarithms, especially for your inverse trigo function. So for example, you're going to have integral of arctangent x, diba? So we don't have such formula for integrals for arctangent x, but we do have integrals that would give us inverse trigo functions, di ba? Katong we have to follow the format du over a squared plus u squared, but we don't have any formula for inverse trigo functions, di ba? So mo na siya. Okay, so in integration by parts, the formula is in this format. So the integral of u dv is equal to uv minus the integral of v du. So if you're going to look at the formula, you're going to have four different variables to discover. So first is the u parameter. The second one is du. Notice that it is just coming from the u parameter. You have to derive u to get du. Next is the v parameter, or let's say the dv parameter, or sige, kuha lang, v parameter lang. Then dv parameter. So four variables that you need to discover or you need to obtain. Okay, so in most cases, if we're trying to, let's say, sequence the variables that you need to discover, so the first one is you need to choose u and v. So these are the first two terms that you need to obtain. Okay, so sequencing. So this one should be the first, and then the other elements are the second in priority. And it's always this case, it's not the other way around because you need to get u and dv first for you to be able to determine v and dv. So what do we need to remember in this case? So in choosing u, so of course, um, probably we know that when choosing u, dapat ma-derive siya, di ba? Because we need to get du. But for the case for dv, so you have three important tips here. Dx is always included in dv. So why do we need to include dx in dv? Because we need to integrate it. Okay, and take note that in choosing dv term, it should be the most complicated factor. So even though that it's the most complicated factor, it should be possible to integrate. Okay. So again, you have to choose the most complicated term as your dv because we need to integrate it. So dapat ma-integrate po nimo ang difficult term. So of course, the u parameter would be the remaining term inside the equation. Okay, so what better way to do this is to solve some problems. So here. So as you noticed in your screen, so upon observation of the different examples, you can say that those are product products of different functions. So for example, number one, algebraic and exponential. Number two, algebraic and trigonometric. So number three and number four, so logarithms and inverse trigonometric functions. So on and so forth. So you can see those are the variations that you need to that you'll be encountering when you try to solve using integration by parts. All right. So let's start off with this example, the integral of x times e to the power of 2x dx. So x will be an algebraic term. This one is exponential. All right. So again, we need to look at first u and dv. Those are the first priority variables. So u and then, so in writing u and dv, so try to write u in this manner and then dv on or diagonally opposite to u. So there's a purpose to this later on why we try to do this in this manner. So again, as what the previous slide states that we need to choose the term that is complicated for it to be dv. So algebraic versus exponential. So exponential is more complicated compared with algebraic, diba? So we write it here, e to the power of 2x, and then again dx is always included in dv, dx. Okay, so the remaining term here would be the x parameter. So second in priority is the v and the du terms. So this one is you derive this one. So you will get du is equal to dx. Then this one you integrate. So getting the v, this one becomes 1 half e raised to the power of 2x. So why is it 1 half? Because again, there's a coefficient in the numerator, diba? EU du. Or if we're going to let u equals to 2x, du is equal to 2 dx. And it becomes du over 2, diba? In the process of katong exponential formula. So that's how we get 1 half e raised to the power of 2x. Okay, so next is we utilize the formula. So after getting all the four variables, we now use the formula. So dali lang siya kay formula based man siya ang integration by parts. So uv minus the integral of v du. So uv, so try to arrange the terms as much as possible. So 1 half x e to the power of 2x, then minus the integral of v du. So that would be 1 half e raised to the power of 2x and then dx. Okay, so this is 1 half x e to the power of 2x minus 1 half integral of e raised to 2x. Okay, so this will give us 1 half x e raised to the power of 2x minus 1 half times 1 half e to the power of 2x plus c. So final answer would be 1/2 x e raised to the power of 2x minus 1/4 e raised to the power of 2x plus c. So this is your final answer. So questions for example number 1.
None, sir.
Okay, so no questions. So let's proceed with number 2. So again, if you try to define the different terms in the equation, so this one is algebraic, the other one is trigonometric. So again, we try to get u and dv. So u parameter is x since it's simple. Then this one is complicated, trigonometric, secant squared x dx. So take note it's complicated and it's possible to integrate, diba? Because we have an integral for secant squared x. Okay, so du is equal to dx. And then getting the integral of dv, this would give us tangent x. So again, there's plus c dapat, diba? But pwede rin na siya ang plus c at the end. Masin pila pa na siya kasi ang inyong ma-generate sa problem, puro gyapon na siya plus c in totality at the end of the equation. Okay, so this gives us the formula now. uv minus the integral of v du. So x, tangent x, minus the integral of tangent x dx. So take note that we have two different integrals for tangent. So as you may recall, there's a positive and negative format, diba? So negative format is negative ln of cosine x, diba? Positive version, ln secant x plus c, diba? So final answer is x tangent x. So if you want it to be positive, so automatically it becomes negative ln secant x plus c. Okay, so if it's plus, it becomes x tangent x, then plus ln cosine x plus c. If it's positive, I mean if it's negative, okay, negative times negative, di ba? All right, so questions for number 2.
None, sir.
Okay, so if balihon ninyo ang dv ug ang kuan, medyo maglisod na sad mo ana kay if balihon ninyo if let's say padung sa let's say ang inyohang u is secant squared x. So getting the derivative would be difficult, diba? Na. Okay, may mo siyang 2 times secant x. Basta murag medyo lisod siya og dagway if murag may mo siyang kuan day na if inyo siyang i-derive, okay, this one is secant x squared man siya, di ba? So this becomes 2 times secant x to the power of 1. Then derivative of secant x, that would be secant x tangent x. So medyo taas siya. And then v would be equal to dv would be equal to x dx. So this one is du and then this one is v. So the v part becomes x squared over 2. Now, so x squared over 2, x squared secant squared x over 2, then v du, di ba? So notice that kung inyong tanaw ng inyong bagong equation, if you try to reverse the dv and the x, okay, medyo dako kayo mo problema, di ba? Tanawa. 2 times secant x times secant x tangent x. Diba? Medyo complicated kining version dire. Yeah, again, since it's still x squared multiplied by another another trigo function, so integration by parts gyapon siya, di ba? So medyo taas-taas na yung solution compared sa kon. So probably the purpose of choosing the most complicated term as your dv para at least masimplify na siya later on afterwards. So sige lang, yung mo na ma-discover sa kuan if mag-answer if magsige mag-answer nga if inyo i-try og bali, so mas molisod sa mo tang inyong equation. Okay? So i-discover lang ninyo.
Excuse me, sir.
Sige.
Pwede mo back sa kadiyot, sir. Okay, thank you, sir.
Okay. So stretching tagamay kay. Okay, so this one is another integration by parts. So this one is logarithm. So how about for the other term? So of course there's an imaginary one here. So let's say 1. This one is algebraic, diba? Para kuan siya. Okay, so next is u and then dv. So of course, if you try to put ln x in dv, wala man tayo formula for ln, di ba? So dito pwede mabutang og ln sa ato ang dv because again, originally the problem is already asking for the integral of ln x niya. If ato siya ibutang sa dv, which also requires us to get the integral, so mana still may tata kay want kabaw sa formula for ln. Now the best way here is to just put ln in the u parameter because as per derivatives, we have a formula for ln, di ba? Let's try ito kana. So for derivative of ln, that would be du over u, di ba? So for For this one, for dv, it will be just dx, 1 dx, diba? Okay, so du over u. So du is equal to dx all over x, diba? Du over u. Then getting the integral, v is equal to x. Okay, so it equals uv minus the integral of v du. So this would give us x, ln x. Again, arrange it as much as you can directly. Then minus the integral of v du. Okay, so cancel out x, cancel out x. What's left is x ln x minus the integral of dx. So the answer is x ln of x minus x plus c. Okay, so questions for number 3. Okay, so no questions. So we proceed with number 4. So this time is we have arc tangent. So again, this one is inverse. And let's say we have a 1 here. Para algebraic siya. Para we can still follow the majority or the definition of integration by parts, that it's a product of two different functions. Okay, so u and then dv. So again, we don't have any integrals for arctangent, so you might put it here because arctangent is impossible to derive. Okay, so this one is dx. So getting the integral for this would give us just x variable. So how about for the derivative of arctangent x? So di ba yung format is du all over a squared plus u squared. Ba? So our a is equal to 1, our u is equal to square root of x. Okay? So if we try to look for du would be equal to 1 half x to the power of negative 1 half, diba? That would be our du. Okay? Sakto, diba? So du is equal to 1 over 2 square root of x. So plugging in the different equations, our du is equal to 1 over 2 square root of x divided by 1 squared, diba? 1 squared plus square root of x squared. And this would give us a du of 1 all over 2 square root of x times 1 plus x. Okay, so this would be du. Okay, so by formula, we now have u minus v minus v du. So u is equal to arc tangent square root of x. So put x in the coefficient lang siguro. Then minus v du. So x multiplied by 1 over 2 square root of x, 1 plus x. And this would give us a simplified version of x arc tangent square root of x minus 1 half integral of x all over square root of x 1 plus x. Okay, so probably you're going to have to use algebraic substitution on this part on the right side of the equation. So let's try. So let c be equal to no na siya dx diri. Square root of x, then z squared is equal to x. Then getting the derivative, this gives us 2z dz is equal to dx. Okay, so let's try to isolate the calculations first. So this becomes integral of z squared multiplied by dx to z dz divided by z times 1 plus z. So cancel z, cancel z. You know, tayo 1 half dali, di ba? Cancel 2, cancel 2. What's left is just z squared all over 1 plus z. Yeah, using long division, kay para kuan, gitaas kay siya nga process, no? So, let's say we try to use long division. Long division. So we have here 1 plus z divided by it's z squared man, no? X is z squared, so this one is z squared. So z squared, then z squared. So you have 1 z squared plus 1, then minus. So you have here negative 1. So that becomes 1 minus 1 over 1 plus z squared. Okay, so this would give us a new term, which is in the format of x arc tangent square root of x, and then minus the integral of 1 minus 1 plus z squared. So that would be 1 over 1 plus, so z squared is just x dx. Ah, ako na siyang gi-simplify further. Di pa din, no? Ato sa ikuan day. Dapat in terms of z pa din siya dapat. Ato pa siya integrate before bringing back the value of the z term. So z squared, and then this one is dz. So notice that the first term is just equal to z. The second term is arc tangent nga formula, di ba? So final answer, so ako lang siya i-simplify dali. X arctangent square root of x and then minus dz. So this becomes z parameter, so minus square root of x and then plus, so this is arctangent. So z is just square root of x there plus c. So final answer would be x minus 1, rather x plus 1 arctangent square root of x minus square root of x plus c. So kano siya padung diri na okay, so questions for number 4. So medyo taas siya, so muna siya. So if you're dealing with inverse trigo function, medyo taas yun ang mga inverse trigo function or mga trigo functions na yung i-deal sa inyong equations. So okay ra? Or nagkalisod na?
Excuse me, sir.
Ah,
So kanang du sir ba? Du is equals to 1 half
ah.
2 square root of x. Ngano sa like final answer sa du sir na multiply ang like denominator? I thought ma-multiply na sa inverse, sir.
Asa dapit ani?
Kanang green, sir, du. O di ba over 1 squared plus square root of x squared mo na, sir.
Mm.
Then confused lang ko, sir, kung anong na-multiply siya sa 2 square root of x.
Tungod ani kani.
Sir, di ba kung mag-divide kag fraction, nya divide na sad mo, sir, di ba ma-multiply man na siya, sir, sa inverse sa kuan function.
Oh, maana siya eh. Di ba? Murag. Pero ang kani siya, I don't think nga imo siyang inverse kay fraction siya, but ang division man gud ana siya, di ba? 1 over 2 square root of x, di ba? Divided by, di ba? Na 1 plus x. Then
Ay, okay, sir.
take the reciprocal of the second term, di ba? So na may mo siyang 2 square root of x multiplied by 1 plus x. So muna inani yung dagway.
Okay, sir, thank you, sir.
So just try to replicate the problem later on para at least you have some muscle memory on how to get things done in integration by parts. So same goes for the other techniques as well. Okay, example number 5. So we have here cosine x as trig function. Then this one is ln of sine x. So this is log plus trig, di ba? As complicated as it gets. So u is equal to ln because again we don't have any integrals for ln, so this automatically becomes sine x, ln sine x. Then this one should be our dv, which is cosine x dx. So getting the integral, getting the derivative. So this one is just sine x, diba? Integral of cosine is just x. So for ln, so again, that would be du over u. So du, so that would be cosine x all over sine x dx, du over u. Okay? So I hope that you were able to follow sa derivation and sa integration aspect. So next is uv minus integral of v du. Okay, so this would give us, so again, try to arrange it in order again. Sine x and then ln of sine x minus the integral of v du. So v is sine x, du is cosine x over sine x dx. So cancel out sine x, cancel out sine x. What's left now is just sine x ln of sine x minus the integral of cosine x dx. So the final answer would be sine x ln of sine x minus sine x plus c. So this may also do with the final answer, or if you want to factor out sine x, so sine x would be equal to ln of sine x minus 1 plus c. So pitira na ang duha answer ni. Okay, so questions for number 5.
None, sir.
Okay, so let's proceed with number 6. Okay, so here you have secant cube x. Okay, so this might be similar to the type A, type B, type C, but of course those can be solved using integration by parts also. So all you have to do is just to break this one into smaller segments. So let's say you're going to make it a secant x, then multiplied by secant squared x dx. Okay? So magkano siya pagkadating, di ba? So the purpose of which is this one might be the complicated term, then this one would be the easy term for u. Diba? So u is equal to secant x, and then dv here is equal to secant squared x dx. Okay, so du is equal to secant x tangent x dx, and then the v portion here would be just tangent x. So uv minus the integral of v du. So secant x tangent x minus tangent x multiplied by secant x tangent x dx. And then this becomes secant x tangent x minus, so we have here secant x tangent squared x, dx. So again, this is type B, case number 1 masiguro ni, wherein you have to plug in the value of the Pythagorean identity. So this becomes secant x, then again Pythagorean identity, secant squared x minus 1 dx. So if you try to expand this one, secant x tangent x, then minus secant cube x, dx, then minus secant x dx. So notice that ang kaniyang term dire nibalik as the same as the original, And if we have to repeat the process all over and all over again, dili ta mahuman og solve sa atong equation. Now try to recall that during your kanang proving na topic sa trigo, The left side must be equal to the right side. So of course, the proper way of dealing with equations is that dapat always siya nakasuwat ang original equation, Secant cube x dx is equal to, so let's say, dapat taning a line dire. So dapat magbalik-balik siya dire sa left side, Ano siya ang proper way. But again, for the sake of saving time, we tend not to write the equations all over again. So at this moment, let's try to write the left side of the equation, the given equation, Muna siya ang given equation. Then the right side is the equation kung asa ta kutob as of the moment, kani siya. So secant x tangent x minus integral of secant cube x dx. Then let's say the integral of this one is ln, negative ln of secant x plus plus tangent x. So plus c na ta na, So notice doing some algebra, short of an algebra, so we may transpose this to the other side, As long as this particular term, the term that is being replicated by the original equation, is opposite in terms, So negative ni siya kay dabalin sa pikas, may mo siya positive kay if positive siya, imong i-transpose sa left side, ma-zero out ang atong equation, which is now invalid. So if we try to again rewrite the equation, secant cube x dx. So again, from minus we transpose, may mo siyang plus, Is equal to secant x tangent x minus ln of secant x plus tangent x plus c. So wala siya. Now since these two terms are equal, so you try to combine it, So you're going to have two of it, 2 integral of secant, So imong isago lang parehag naong, so duha na sila kabuok, So 3 secant cube x dx is equivalent to secant x tangent x and then minus ln of secant x plus tangent x plus c. Now divide everything by 2 so that our final answer would be secant cube x dx is equivalent to 1/2 of secant x tangent x minus ln of secant x plus tangent x plus c. So this would be your final answer. So mas better siya, di ba? So arira ko to bang atong parenthesis day. Kaya ang c, maski hindi mo siyang i-multiply og 1/2, it's still c. So again, if mo repeat ka na inyong given, di ba kani siya? So kani siya, ni-repeat 3 the pita, and it's the opposite operation of the given function. So you may proceed with the transposing method, di ba? Yung i-transpose on the left side para ma-combine siya together with the original equation. So again, ma-combine siya because again, at first, we really have to rewrite the original equation and then the right side is the solution, di ba? That's the proper way of doing calculations. But again, for the sake of saving time, muna siya, we tend not to repeat writing the given all over again and again. Okay, so questions for number 6. Okay, so probably there's no question. Okay, so let's proceed with number 7. So again, exponential, and then this one is trigonometric. Exponential, and then the other one is trigonometric. So let u be equal to one variable. So most likely cosine or the trigo function is the simpler one. The complicated one is the exponential term. So we set it as e to the power of x dx in the dv term. So di ba if you try to recall our discussion before, so we started off with trigo and then we went to inverse then exponential hyperbolic, di ba? So probably that's the degree of on how much it is complicated. So du is equal to negative sine x, and then dv is just equal to e to the power of x still. Okay, so uv minus integral of v du. So e to the power of x cosine x. So again, I arrange it in a manner of same as a given, di ba? Instead of being cosine x e to the power of x. So ako lang siyang same format sa given kaya para mas dali siya sabton. Then next is we try to get e to the power of x, then minus sine x dx, di ba? So ano na siya dx dire. So rearranging it again by multiplying by negative 1. So this becomes plus then ex sine x dx. So notice that the remaining integral is still a product of two different functions. So meaning you have to do the integration by parts again. So in most cases, if may mga problems wherein you have to be doing multiple times of integration by parts. So probably mga at most 3 times siguro inana. So let u is equal to sine x, and then dv is equal to e to the power of x. Oh, sorry. Okay, so sine x, so this is du is equal to cosine x dx. And then dv is still the same, e to the power of x. So if we're going to write the equation again, e to the power of x cosine x, so plus, so I try to put it in parentheses because it's two terms, diba? uv minus vdu. So uv, that would be e to the power of x sine x, then minus the integral of vdu, e to the power of x cosine x dx. Then getting rid of the parentheses. So muna ang purpose sa akong parentheses is that, for example, this one is negative. Para inig-distribute na ako sa mga signages, di ko maglibog, di ba? So muna purpose na ko why I try to put it in a parenthesis first. So just to avoid confusion on the signages sa signs sa inyong operations. E to the power of x cosine x dx. So again, if I punta sa atong original nga equation, di ba? Ex cosine x, ex cosine x. So again, this is the time that you're going to transpose on the left side. So this would give us 2 integral of e to the power of x cosine x dx is equal to e to the power of x cosine x plus e to the power of x sine x. Then divide everything by 2, so the final answer will be 1 half e to the power of x cosine x plus e to the power of x sine x. So if you want to further simplify it, so extract e to the power of x, so this becomes 1 half e to the power of x cosine x plus sine x plus c. All right, so that would be number 7. So again, ang kuanan niya kay di ba magsitag suwat ani balik-balik, di ba? The proper way na. Then again, we don't really need to put it always because kapoy sig suwat balik-balik, di ba? So this time lang because the given equation kay nibalik siya. Okay, so let's go to number 8. So again, this is algebraic. This one is exponential. So u is equal to x squared. So obviously that's the simpler term. This one is dv e to the power of 2x dx. So du is equal to 2x dx. dv is equal to 1 half e raised to the power of 2x. So hopefully by the time that you're going to review the recording, so at least you'll be guided since colorful kaya ang slide, di ba? So uv minus vdu, so you're going to have it as 1 half x squared e raised to the power of 2x. Then minus the integral of vdu. 1 half e to the power of 2x, then multiplied by 2x dx. So cancel out 2, cancel out 2. What remains is 1 half x squared e to the power of 2x minus the integral of x e to the power of 2x dx. So again, notice that the remaining integral is still a product of two different functions. So we're still going to have to use the integration by parts again. So let u be the x variable because that's the simple variable, and then dv is equal to e to the power of 2x dx. So this will give us du is equal to dx, and then dv will give us the same as the one above. That would be 1/2 e raised to the power of 2x. Okay, so the equation now becomes 1/2 x squared e raised to the power of 2x, then minus, so again parenthesis, because this time is negative, diba? We have to be careful with distributing negative signs. So uv, that would be x, or there 1/2 x e to the power of 2x minus v du. So integral of v du. So 1/2 e to the power of 2x, then this one is dx. So eliminating the negative sign, so this is 1/2 x squared e raised to the power of 2x minus 1/2 x e raised to the power of 2x. So minus minus, diba? This one is now plus. Plus 1/2 integral of e to the power of 2x dx. So the final answer would be 1/2 of x squared e to the power of 2x minus 1/2 x e raised to the power of 2x. So this one is now 1/4, diba? E raised to the power of 2x plus c. Okay, so most likely if you are dealing with algebraic with any power, then multiplied with any function, there's a shortcut solution for this one. So again, as long as it's x to the power of n multiplied by any function. Yeah, muna siya ang shortcut. So all you have to do is to create a table. So probably this is the fastest way to do it. So table, this one is in terms of the u parameter, this one in terms of dv parameter. So the u parameter is always this particular um, algebraic function x to the power of n. Then any function is going towards the dv. So left side derive, right side integrate. So starting off with 2, rather x squared. So this becomes 2x. The next it becomes 2. The next it becomes 0. So stop at sa 0 kay wala may like other kanang derivative sa 0, di ba? Mga siya pinaka-last. Okay, so next is we go towards dv. So e to the power of 2x. The next is 1/2 e to the power of 2x. Then integrate the second line. So you're not referring to the first line. There's always the next. It's always consecutive ang iyong pag-derive and pag-integrate. So this one becomes 1/4 e to the power of 2x. The last one becomes 1/8 e to the power of 2x. So this is where the shortcut comes in. So you have to cross multiply. Then the signs or the operations for each term, this one is plus, this one is minus. So alternating na siya. Plus, minus, plus, minus, plus, minus. Okay? So notice that if you multiply the first two kaning kuan, this is equal to the first term. 1 half x squared e raised to the power of 2x. So next na punta. So if you try to multiply the second line, na second diagonal line, so take note that 2x times 1/4 e to the power of 2x gives you this term here. And then lastly, for the third diagonal line, this one, it gives you this other term. So shortcut siya, di ba? Shortcut. Again, only exclusive for these types of functions kani siya. So if di siya inani, so you cannot use the shortcut. So imagine if you have x to the power of 7. So if inyo siya manual solve, so you have to repeat the integration by parts 7 times, di ba? So kani twice na gani siya kay it's squared, x squared. So if it's x to the power of 7, so dako na kayo, di ba? Dako problema. All right, so any questions or clarification so far sa atong gidiscuss? Okay, so no question. So if there's no more question, so I think that would be it for this session. So see you all again on Thursday for our last topic before the midterm exam. So also I already extended all the deadlines of the assignments by 1 week. So syaro dili makakuan by 1 week, di ba? So kudos to those who were able to pass the assignment on time, or rather before pa jud sa deadline nakapass sa assignment. So kudos to you guys kay at least nakuha na inyong burden, di ba? So for those who haven't yet submitted, so of course the burden will still be in effect up until you submit your assignments. All right, so try to um, make your assignments first. So yan na party-party. At least maka-party-party ra mo after aning kuan. All right, so see you all on Thursday and study in advance. So thank you all and God bless.